So what if you could write an app, but instead of having to mess with all the technical details, you could simply specify the views that run on the front end and the routes that run on the back end? And what if this made creating apps easy enough that anyone could do it? That's the dream for Xylo, and I have a first cut at what it could look like. Let's check it out. I'll start by showing you a demo of what it does. Then I'll show you how it works. I learned a ton of new things about Rust while making this. Finally, we could talk about what's next, because boy do I have a lot of work to do on this. I've also written an article that has more details. The link is in the description. And the source code for Xylo is of course on GitHub. So what do we have so far? Really, the only thing you can do is create a project. You do this with the Xylo new command. Once the project is created, you can cd into it and run Xylo dev to start the front end and back end servers. You can open your browser and look at the front end. It's just a blank Next.js website for now. The back end is actually just a thread that's sitting there printing a message and sleeping forever. It does nothing yet, but eventually it'll handle requests from the front end. The files generated by the Xylo new command show where I intend the project to go. You have a front end folder to hold user interface code and a back end folder to hold server code. Plus, if you peek in the .xylo folder, you can see what's going on behind the scenes and even make temporary changes if needed. You get to see the truth. It's just a Next.js app and a Rust app running together at the same time. That's it for the demo. Not the most impressive, but it's a start. Let's jump into a code tour and talk through the main Rust lessons that I learned from this project. Code tour. I learned a lot about Rust while making this little MVP. In particular, there were lessons about making a CLI, launching and managing processes, and filling in a template by copying files. Implementing CLI with struct-opt. Coming from the Python world, I was used to argparse. Rust traits and enums were foreign to me. So the syntax used by struct-opt felt a little strange. Once I finally bit the bullet and defined all of the traits and enums, I was pleasantly surprised at how well and how easily it worked. To use struct-opt, there are a few steps. First, create an enum to hold your CLI structure. Next, add annotations. The first annotation will mark that our enum derives from struct-opt, debug, and partially queue. Then, add a second annotation to tell struct-opt the name and description of your command so that the help menu can be auto-generated. Finally, add variants for the enum. Each variant represents a subcommand for your CLI. Variants can have data associated with them, and struct-opt uses this data to add arguments to your subcommand. This will make it possible to use the Xylo new command with a project name argument, or Xylo dev just by itself. Next, parsing the args into a variable is incredibly easy. We can now use the args variable to make decisions based on the arguments passed by the user, and if the user passes bad arguments, struct-opt takes care of letting them know with a helpful message. Process management with command. An important part of this MVP was figuring out how to manage processes using Rust. To get this done, we need the built-in standard process command struct. Thankfully, this was pretty easy, just a few lines of code. If you want to change directories before running the command, you can use current dir. Here's an example. Managing background processes with Control-C. Things get a little more complicated if you want to run a process in the background. For Xylo, I needed to run the front end and back end at the same time. To make this happen, we need to start a thread, which is also fairly easy in Rust. Here's a start. It prints a message every second forever. Next, we'll want to actually launch a process and wait for it to complete. For this, we'll have to use child instead of command. It's pretty similar though. After it has been created, we wait for the process to finish. It's a little messy though because you have to hit Control-C multiple times to get it to exit. If we catch and handle the Control-C signal, we can clean up our program's resources and exit right away. We can do this by using a shared variable across the separate threads. Next, set up the handler to modify this variable when the user hits Control-C. Finally, modify the loop above to check this variable instead of looping forever. When the variable is set to false, kill the child process so that we can exit cleanly. Templates with Rust Embed and walkdir. Xylo generates projects by copying templates into a new directory. This presents an interesting problem. Where do we copy the files from? Do we need an installer to copy our template files somewhere onto the user's system before they can use it? Or is there a way to bundle everything into the executable so we don't have to worry about it? For Xylo, I went with the last one, embedding files. The Rust Embed package lets us do just this. Initial setup is very simple. Just declare the folder where your assets will be stored. Then you can use that asset struct to iterate your template files and do whatever you need to do with them. Another good skill is iterating directories with walkdir. This lets you check every file in a directory recursively and do something with it, like syncing two directories. Testing and design. I tried to implement everything with test-driven development at first, and I learned a lot about Rust testing while doing so. However, I gave up after a bit of trying because I'm trying to figure out how to make the prototype work and get the interfaces right. And for me, this is almost impossible while also worrying about keeping 100% test coverage. I'll need to go back and do things properly once the basics have been figured out. It would be good to redesign all of the code to use dependency injection and classes that use solid principles so that I can properly unit test everything. I added one integration test that invokes the new command programmatically. It took several seconds to run at first because I was running the npm create next, npm install commands directly. However, now that I'm just copying template files using Rust Embed, it runs fast as lightning. Next steps. My next step is to tie the front end and back end together somehow. I want this to be as easy as possible, so I'll need to design this carefully. I want to refer to this concept as routes. A Xylo route will be accessible by some easy-to-use API from the front end, and if I can figure out how, also from an auto-generated command line interface. I'll need a real-world app example to drive development. For this, I'll use Boom languages, which I've already rewritten like 5 times, so why not 6? The first feature I'll try to implement will be flashcards. I hope to support exporting a single Xylo codebase as a server-side backend and web-based, desktop-based, and mobile front-ends, all from a single codebase. That's going to be a tall order, so for now I'm just going to stick to the backend and a regular old web front-end. Later I'll use Tari to turn the web front-end into a desktop app, and I'll use Capacitor to turn it into a mobile app. Thanks for checking out this MVP. I hope the lessons I shared were useful to you. Be sure to subscribe to stay in the loop as I make this whole Xylo thing a reality.